We're going to jump quickly into recursion relation. We're not going to spend too much time on it. We're going to fly through it. That's that. So recursion relation, essentially where you generate terms and you have these little relations here. They look like Vn plus 1 equals Vn plus 3, and then Vo is 1. So then you go, all right, so the first value is 1, 1 plus 3 is 4. The next value, so V1 is 4. So then I go V4, so I go V1, so that's 4, 4 plus 3 equals 7. It's just very simple sort of maths. It just gives you things in an order. You can make them into nth term when they're just an arithmetic sequence where they just add up or subtract. There's no multiplication or division. And as you can see there, you go Vn plus 1 equals Vn plus d, whatever d is. Or you go Vn equals V0 plus n times d. So if you want to find the fifth term, you go 5 times whatever the d value is. So as you can see here, calculate U4. So in this case here, you've got U0 equals 2. So what you would do is you would go U4 equals, so coming back to this, you go 2 plus, and I wanted 4 times 4. So you get 16 plus 2 equals 18. Very simple way of doing it. So as you can see, you can go about it the long way like that, or you can do the nth term, and it's much, much quicker. So that's how you go about it there. So then you have geometric sequences, which are a little bit more complicated. Geometric is where they go up or down. And so they're either multiplied or divided. No matter which one it is, multiplication or division, if you use an nth term, you go r, which is the same value as it's what d was, but now we use r because it's geometric, r to the power of n. And so in this case here, as you can see, I want to find u4. I've got 2 as my original value, and my equation is 2u. So I go 2 times 2, 4 times 2, 8 times 2, 16 times 2. Very boring. Or I go u0, which is 2, times by 2 to the power of n, which is going to be 2 to the power of 4. 2 to the power of 4 gives us 16. You can just do that in your calculator. 2 times 16 is 32. Much quicker way of doing it. So that is essentially your recurrence relations. Then you have sort of this understanding that you can have a general linear equation where you have both an r value multiplying or dividing, and you also have a d value adding or subtracting. Really important, there's no nth term formula for this. You just have to do it. It's really a bit of a pain, but you've just got to go about it. There's no way of doing an nth term for it. You just have to keep doing it, as you can see there. So if you look at a sort of practice question for this, it says the first term in a sequence is 3. The second term is obtained by multiplying the value of the first term by 5, then subtracting 2. The third term is obtained by multiplying the value by 5 and subtracting by 2. Cool. This pattern continues. So we're multiplying by 5, we're subtracting by 2, and the recurrence relation which generates the sequence is. So the first term, which is t1, because it hasn't said it's the original term, which is 0, it says the first term, is 3. So they have to have t1 equals 3. They've all got t1 equals 3. Cool. Then it says the second term is obtained by multiplying the value of the first term by 5. So we need to multiply the first term by 5. So multiplying by 5 happens here, doesn't happen here. Multiplying by 5, well, that's negative 5, so that's not it. That's negative 5, that's not it. That multiplies by 5. Now, really important, how can I tell this one's the answer? Because the tn plus 1 should be on this side and the tn should be on that side. So that's correct there. The answer here is B. So that's how you go about a question like this. This is a pretty straightforward sort of recurrence relation question that I'm sure you're all on top of. So pushing on. The next step in this is understanding your financial terms. So this is a page I would expect pretty much all of you to have something like this in your summary book somewhere, so that if you are asked to describe a term that is in an exam, you can sort of come back to it and go, all right, this is how I go about it. Because this stuff can be quite difficult if you don't really remember the terms, and it can get quite confusing. So let's just quickly go over each of these terms. I'm sure you'll read through it yourself, but an investment, I'm sure you all know what an investment is. You put money into an account or an asset, and you sort of get money back. So the investment is how much money is being put into an account or asset by an individual. So it's sort of how much money you're putting in, and then you should essentially get money out. A loan is the sum of money that a person borrows from the bank that incurs interest. A principal, this is the initial value that was either invested or loaned. So it's the initial value. That's the principal is the initial value. The interest is a portion of money that is added every period, usually as a set percentage, increasing the sum of money owed or earned. So interest is essentially just money added on top. So if you give the bank money, they're going to give you interest because they're borrowing your money. If you steal money from the bank, well, you're not stealing, you're loaning, you're taking money from the bank. So they're giving you a loan of money. You are going to pay interest on top of that when you pay it back because they are giving you money. So then their way of making that profitable is you need to pay them a little bit more back. Essentially how a mortgage works. Withdrawal deposit. Withdrawal means taking money out. Deposit means putting money in. And then per annum means per year. So you'll see PA, that means per year. So per annum is per 12 months or per year. So that's another important definition as well. You need to know what per annum means. It comes up all the time. Please don't try and don't forget what per annum means. It's always going to come up. So interest is calculated. So let's go through each of the different types of interest. So we're going to go through simple interest and then compound interest. And then we'll go through our depreciations after. So we'll start off with simple interest. Simple interest is, as it says, simple. This shouldn't be difficult. Interest is calculated only once on the initial amount of the principal. So essentially, the D value here is using this formula here. So the best way to go through this is an example, but essentially, interest is earned on the original value and it's added every time. So if D is less than 0, you have a decreasing sequence, which means interest is charged. If D is greater than 0, you're earning interest. This will always be simple interest, will always be this. Why is that? Because if it's not, it's going to be simple depreciation. So Tom invests $5,000 into an account that earns 10% simple interest per year. How much is Tom's investment worth after 5 years? So have a thinking. For those of you who are at home and are watching the recording, not the premiere, I highly suggest pausing this and having a go. Jump back to this slide if you need. So jump back in and have a look at this slide. But I want you to have a go. I want you to pause and have a go. Let's do it at the premiere. You don't really have time to do that. I do apologize, but we're going to go through it straight away. So those of you at home, pause, 3, 2, 1. And now we're going to go through it. So we have $5,000 and we want to figure out what the D value is. So D here is going to equal V0, which was 5,000 multiplied by R over 100, which is 10 over 100, which is going to equal like 0.1. And therefore, we are going to get a value of 0.1. That'll be 10%. 10% of that will be 500. So our simple interest is going to be 500. So then we have our formula of Vn plus 1 equals Vn plus 500 with VO equal to 5,000. So we can just use nth term here and we can go, all right, what are we looking at? 5 years, V5 equals 5,000 plus 5 times 500, and we get a value of 7,500. Important with finance, you put the units on at the end. It's really important you have the units at the end. You always need to put the units on. So that's the value of the investment after 5 years is 7,500, and that's how you go about that question there. So simple interest, simple question. I'm going to be honest with you, simple. If it has simple in it, it's a very simple way of doing it. It's pretty self-explanatory. You're not going to need to stress about it. So moving on. There's the answers there if you want to work through it as well. So compound interest. This is where things get a little bit more complicated. Now, what's really cool about compound interest is you can do it all on the Casio with the financial solver. We're not going to go through that right now. Financial solver will be in a little bit, but you can do this in the financial solver. But for now, we're going to go through how to do it by hand. So interest is calculated each compounding period from the current total of the investment rather than the principal. So the number of interest periods is the number of years, which is n, is the number of years by the number of periods per year. And then the interest rate is the percentage per period R. So rate per annum divided by the number of interest periods per year. And that's R. So let's go through how to do this, because all of those words can be very confusing. So Howard invests $700 and into an account that pays compound interest at 7.1% per annum. Find the value of the investment after 3 months. Now, this question does not give you enough information because it should tell you what is the, like, when are we getting interest. So it's 7.1% per annum paid per month. So really important, it needed to say like the compound interest per month. It didn't say that, so this question's actually wrong in a sense. It needs to tell you. So I've added it in there, apologies. I should have added that in there when I sort of put this question down. But essentially, this is saying, all right, there is 7.1% per annum, but it's paid per month. It's not paid per year, it's paid per month. So having a look at this question, what we first need to say is, all right, what is our percentage per month? Because we're going per month, so we're going, all right, this is going to be 7.1 divided by 12, which is going to equal 0.59% per month. So we have 0.59% per month. Now I need to find each of my values. So you can go about this sort of in an nth term way, because if we think about it, what we're going to get is we're going to get Vn plus 1 equals zero. It's a little bit confusing. So it's going to be 1 point. Actually, that's probably the wrong way to go about it. I'm just going to apologize. That's the wrong way to go about it. It's going to be, it is actually going to be that. It's going to be Vn plus 1 equals Vn times by 1 point, and going back to this, it was R divided by 0 divided by 100. So 1, 2. So it's going to be 0.059 and 0.059 or 0, yeah, 0.059. And essentially here, what you can do is you can sort of square it or cube it, but it's safer with compound interest to not do that. It's safer to just say, all right, let's do each of the steps. So you go through each step. So you go through, all right, the first month. So first month is going to be V1 equals 700 times by 1.0059. And I get my value, which would be, apologies, times by 1.0059. And I get 704.13, and then I run through the next two. So I go, all right, V2 equals 704.13 times by 1.0059, and then I would get another value, which would be 70 times by 1.0059, and then I would do that again, and I end up with a value of 712 for our third one, 0.46. So, as you can see here, the answers sort of go through it. You can cube it, but sometimes it can be a safer bet to go through them initially. But as you can see there, you can do your nth term. There are occurrences with this where you have to use financial solver because the nth term won't work. But as you can see here, you could have done nth term. That's where I was getting a little bit confused. I was like, wait, and I was thinking financial solver. So that's your, whoops, that's your answer there. And as you can see, you could have done it by an nth term way as well. Now, how did I get, people ask, how did I get this value here? I used this formula here. So I went, all right, my little r value is this one here. So I had 0.59. So I went 1 plus 0.59 divided by 100, and you end up with 1.0059. That's how you go about it. So now let's look at flat rate depreciation. Whereas this is sort of like simple depreciation, but you just get given a value usually. Again, it's the same thing as simple interest in terms of that it's like a percentage of the original price, but usually you're just given a value. So you go VN, take D. So it says here, Emily bought a car 18 months ago at $2,500, or $25,000, so 250, it was recently valued at $10,000. Assume flat rate depreciation, find the depreciation rate per annum. So let's find the difference first. So 2,500, or 25,000, sorry, take 10,000, and that's going to equal 15,000. So that's our difference. So we have 15,000 as our difference. Now, we want to find it per annum, so per year. How many years have there been? There's been 1.5 years. So let's find the rate per, find the depreciation rate. So let's find that rate. We go 1,500, or 15,000, sorry, divided by, I keep saying 1,500, 15,000, divided by 1.5, and you'll get an answer of 10,000 per year. And then it says, it wants the rate. So this is the value. We want to find the rate. So we want to find the rate off the original. So we're going to go, all right, 25,000 divided by 10,000. And that's going to equal, it's actually the other way around, sorry. My bad. You want to do 10,000 divided by 25,000. And you're going to find a value of 0.4, which is essentially 40% per annum. If I move across, I think I should have that answer. I do have that answer, 40% per annum. So I found that the rate per annum in terms of money was 10,000, but I wanted the actual sort of the rate. This is the percentage. It's asking for the actual percentage per annum, which is 40%. So again, these questions are about finding out what they want. What do they actually want here? They want the percentage. That's what they're asking for. That's what they're going to get. So that's your simple interest version of depreciation. Then we have the value of something decreases as it's produced over, produces more output. This is what we refer to as unit value depreciation. So there's a fixed amount of depreciation per unit of output. So you could say like a printer, once it prints 100 pages, it loses $10 of value. D is the depreciation for every unit of output, and then the unit of output is N. So be careful, the value of N is constrained in real world examples, as eventually a value of an item will be $0 and it cannot be worth negative $100. So it's like a car, and as a car travels set amount of kilometers, it loses set amount of value. You can't say that your car becomes worth negative money. It's not what happens. You don't then just give it to someone and they pay you to take it. That only happens if you crash the car. So really, really important that you understand that this is real world example. It's like it's restrained within that real world example, and it has sort of that, like, you can't go into things that don't make sense. So it has to have its effective life within a real life example. So there's no example for that one, but essentially think of it like a printer. So think of it like a printer, and you say, all right, it loses 10 cents per 100 pages. So you could say D would be 10 cents, so it'd be 0.1. And it's per 100 pages. So N is the value per 100 pages. So you say, all right, there was 2,000 pages printed. If there's 2,000 pages printed, your N value is 20. So you'd go 0.1 times by 20. And you get your value from there. So really important, that's sort of how you go about that there. So you go, all right, 0.1 cents per unit, and there were 20 units, therefore, because there was 2,000 pages, which is 20 times 100, and therefore we get whatever value that would be. It would be like $2 off the value of the printer. So that's unit value depreciation. That's like an application of that there. Now what we get into is reducing balance depreciation. Now, reducing balance depreciation is going to be done mainly on your financial solver, and we're going to go through an example where you don't use financial solver, but it's quite important that this is mainly going to be done on the financial solver. So the value of something decreases as it gets older, basically a decreasing geometric sequence. So as you can see here, you have Vn plus 1 equals RVN. So as you can see here, you then have another equation that says R equals 1, take R divided by 100, where R is the depreciation rate in percentage. So let's go through an example. A printing press, so again, we talked about a printer before, is purchased for $15,000 and undergoes reducing balance depreciation at a rate of 3.5% per annum. What is the value after 5 years? So, how are we going to go about this? We first need to find out R value. So, R value, R is going to equal, and it was 1 take, little r, which here it's per annum, we're looking at 5 years, so it's going to be 3.5 divided by 100. And we're going to end up with a value of 0.965. So we get 0.965. We then need to make our formula. Our formula is probably best going to be Vn equals 0.965 times by n times by VO was 1500. So then we go, all right, I want to find after 5 years, so I'm going to go 0.965 times by 5 times by 1500. And, oh, sorry, that's going to be to the power of. I think that was wrong in the last slide because I think I forgot to put subtext. Going back. This should have been subtext, everyone. Sorry, this is an error. I will fix that before these slides are uploaded. That needs to be N. Now, just let me write a quick note in my phone to fix that. I do apologize. That shouldn't have been like that. Change R to supertext. What slide number is this? And this is on slide 84. I don't know why there's two 84s there. All right, we're on slide 84. So that should be supertext. I was like, wait, that does not seem right. It needs to be supertext. So this is going to be, if I fix this up now, apologies everyone. This will be to the value of n times by 1500. So again, this is going to be to the value of 5 times by 1500. And you end up with a value of, I'm going to do that in my calculator. The power of 5 times by, I get 1200, 552, which will approximately be the right answer. So 1200, 552. I think I have the right, yep, $52. So that's what we're going to get there. So that's how you go about that question there. Really important that that's how you do it. All right, so the answer on the next slide, moving on. So now we get into reducing balance loan. This is really where Financial Solver comes into it, and it's really, really, really essential. So this is where you combine geometric and arithmetic sequences. You get a loan. With the loan, what happens is you earn interest on top of it, so that you don't earn the interest, you pay the interest on top of it. So interest is earned on top of whatever the principal is at the time. So the loan goes up. Every single time you go to pay it, the loan goes up. Then you pay it. So let's just say you're at $5,000. Take a $5,000 loan. Your first repayment is going to be $300. But what happens is you're earning, there's 1% interest on it. 1%, essentially, when you go to pay that $300, you're actually going to pay it off $5,050. Take the $300 because that has the 1%, which is $50, added to it. You take the $300 off it, it's going to be $4,750. Then the next time you do it, you're actually going to pay off $4,750. It's going to be $9,750. That's what you're going to be paying, and you'll be paying $300 off that because that, again, has the 1% added to it. And that's how you go about that. So that's why these are really, really messy. There is no nth term. That's why you have Financial Solver. Essentially, this is always used when you have a big loan, like a home, like a house mortgage. This is where this is used. Now, there's no example right here for this because we're going to go through an example later on. So we will go through an example of this, don't worry. I just want to go through just the last couple of things before we get to the examples that I have at the end. So effective interest rate, these really don't come up much, but they can be tricky to understand. It really just converts what is a compound rate to a flat rate? So if you're earning, well, let's just say we're paying a loan and the interest rate is 5% per annum compounding monthly. When it compounds monthly, you actually pay more than what the 5% is. You'll note that if you did, so if you do a calculation and you say, all right, I have my loan, and if the interest is 5% at the end of 12 months, every 12 months, it would be, go up by X amount. Now, if I actually earn 5% per annum, but it compounds monthly, so it compounds at, 5 divided by 12, 5 divided by 12, sorry. So it compounds at 0.42% per month. That's what it does. Eventually, it's going to reach 5. Overall, it'll be 5% after the 12 months. But it's compounded monthly. It's actually going to increase the loan more. So compounding at a quicker rate, so compounding like, monthly, fortnightly, daily, the more it compounds, even if overall it's the same percentage, it's going to increase it by more. So what actually did we increase it by? What is the actual interest rate? Because if overall the percentages add up to 5%, but the actual value that was increased is more than 5%, what is that value? Is it 5.1%? Is it 5.2%? Is it 5.05%? What is that effective interest rate? That's what that is. So it allows for comparison between two sort of techniques. So if you go like, compounding monthly versus compounding daily, you use the calculator. All the calculators now, I know with the new updates have them. My calculator doesn't because it used to not, but they all have this formula within them. But you need to have the formula in your data booklet. Oh, sorry, your summary book or your bound reference. It has to be in there. This is another non-negotiable. You need to have this in your summary book. The 2022 Northern Hemisphere exam had this in reverse. Usually this goes from your compound to what is your effective. They actually had the opposite. They went from the effective back to the normal. And you couldn't do that on, I believe, this Casio, or maybe it was the team. One of the Casios could not do that by just saying, like, this is how you do it. They couldn't just do it. They had to know the formula and put the formula into sort of just like the main page and go X where the normal interest rate would have been, and then put equals the effective interest rate and then solve for X. That's what they had to do. But that was sort of difficult for them. Like it was difficult at the time because it had never been done before. So I know overall it wasn't answered very well. It was difficult for that set of students. For you guys, it's not going to be because you know how to do it. So really, really important that you have this formula in your data booklet, despite the fact, your summary book, data booklet, I keep saying data booklet, summary book, despite the fact it is in the Casio. So, as you can see here, this is the formula. I need this in your summary book. You need R effective equals 1 plus, and then you have all of this, but essentially your nominal annual interest rate and your number of compounding periods is important. So your nominal annual interest rate is your interest rate per annum. So if it says 5% per annum compounding monthly, you go 5 here, and you go your number of compounding periods per year. This is 12, and this is 12. And that's how you get your R effective. In their case, they were given, 5.2 or something, and then they were given compounding periods as 12 and 12, and they had to find I. So you just put X there, and you put it in a calculator, and you go solve. You write all that out, and you go solve, and that's how you found it. But you needed this formula to be able to do that. So those who didn't have it in their summary book weren't able to do this question. So it's really important that you have this in your summary book. And then we have two more things, well, three more things technically, but two more sort of things that are pretty cool. So we have an annuity and we have a perpetuity. So these things are very similar, but slightly different. The annuity is essentially where, think of it like a super. And essentially what happens in an annuity is where an account earns interest and there are either withdrawals or further investments. Usually, these are withdrawals. Annuities are generally withdrawals. So, I'm going to change this and go negative D. They are generally withdrawals. They're generally used as like a retirement fund. So essentially, when people retire and they've got a bit of money that's not in their super, it stays in their account and they put it in an annuity account. What that means is that account earns interest. And so that account gets bigger. but every month or 2 months or 3 months, they take a set amount of money out. That money that they take out is more than the interest earned. So the interest earned might be $100 the first time because it'll be earned depending on what's in there, so it compounds. But then they take out $300. So the principal gets smaller. And so essentially every time the interest they earn gets smaller. And eventually this will reach zero. This will reach $0 and the whole thing will be spent. A perpetuity is different to that in the sense that the money that is earned as interest, that money comes out, but the principal stays the same. So if you earn $150, I don't know, let's just say per quarter in interest on this account, you take out, your withdrawal is $150 per quarter. So you're always going to earn the same amount of interest no matter what. It's just you're going to take that interest out every time. So that's why you earn the same amount of interest. It's still compounding and it should be different, but because you keep the principal the same every time, it never changes. Really common example of this is scholarship funds. So you look at those places that always offer out scholarships, and they always offer out pretty large scholarships, and you're like, how do they do that? They have a ginormous perpetuity that gives them all the money they need for those scholarships every year. And every year, those scholarships are pretty much free because it's just the bank's interest. So they've given the money to the bank, so the bank pays them the interest. They take that interest out as the perpetuity, as the scholarship. So that's how that works there. Slightly different, that's how it works. And then amortization tables are the last step. These things you just need to have in your summary book. I'm not going to go through them in detail because they're sort of the last step. And for those of you who haven't done financials, most of you, this is the last thing you do. So I'm not too worried about going through them today. But essentially, they just show either compounding interest or compounding reducing balance loans. They just show that in a sort of a table sense. So as you can see here, the balance of the loan, it says the payment amount, the interest paid. So there's interest that was added on top of this, and then how much the actual principal went down. So you take this away from how much you paid because you're paying off that interest. And then as you can see, the principal went down to that. Same thing, you're paying off the same amount. This time the interest got smaller because it's a smaller principal, and therefore you paid off slightly more, and so forth, and eventually get down to zero. So that is an amortization table. Now, I think the best way to learn financial, as I've discussed, is to do practice questions. So once you've done your textbook, you need to move on to exam style questions, SAP style questions, because that is how you're going to learn. So I've set up 1, 2, 3 questions here. We're just going to go through them. I'm just going to go through them and just continue on. For those of you who are at home and are watching the recording rather than the premiere, this is the first one. Take a quick screenshot, go through this one. This is the second one. Take a quick screenshot, go through this one. This is the third one. Take a quick screenshot, go through this, and then come back. So pause your video now, come back, and we will go through the answers for you. Those of you at the premiere, we're just going to go through it. So a computer is purchased at $1,750 and depreciates 20% per annum. Calculated monthly using reducing balance method. The computer has a scrap value of 700. How long will the computer last before the value is less than the scrap value? So once it reaches the scrap value, it's no longer useful. So the best way to go through this is to use your financial solver. So how are we going to use the financial solver? My big tip for this is whenever you use the financial solver, you write down on your book what you use. So I'm going to write down in my question, and this is working out. This counts as working out. You go, all right, N equals, well, I want to know N. I don't know how many months it is. So N is months or whatever period it is, number of periods. I don't know the number of periods. So N is my question mark. I'm going to go I equals, and this is always, you put this always in as per annum, 20%. All right, I want to know my previous value. So this will be my principal value. My principal value is 1,750. Now, really important, is this negative or is this positive? Because did I, give the money to the bank or spend the money, or did I gain money? I spent the money. So this is going to be negative. Then it's how much are the payments? Well, there's no payments here. I'm not adding money to it or taking money away from it. So that's 0. What is my future value? I want to know when it's worth $700. Now, 700 is positive because that's how much it's still worth. So that's how much money I've technically still got. So I want to know when it's worth 700. and then my PY/CY, as I said, it's a bit useless. You just put it as the number of periods. So the number of periods within a month. So I'm using 12. So number of periods within a year is 12 because I'm using months. If I was using quarters, I put 4. If I was doing yearly, I put 1. So that's what you put in both of those boxes. So that's my working out. I then go to my calculator and I do it in my calculator, and you'll find that your answer here, complete manually with Financial Solver, I get the answer of 55 months. So how long will it take for the computer to be less than its scrap value? That's 55 months. So really important. Now, this answer here, I believe, is something like 54 point something. Let's just say 54.8. I don't know what the exact answer is, but I think it's something like 54.8. And so when you get 54.8, you need to be like, all right, I know this is going down. So as this is going down, I need to say, all right, because this is going down, like, I need it to be below that value, and it's done monthly. At 54 months, this isn't going to be below the scrap value, but at 55 months it is. So therefore, at 55 months, that is going to be my answer. Not 54.8, because I want to know at the exact month, because you can't be halfway through it, because it's compounded monthly. The other thing here that I probably got wrong was I need to put negative percentage in, sorry. Why did I do negative percentage? Because here you're actually going down. You need to make sure that you know that it's not earning interest on top of it, because this hasn't been put into a bank. So it's really important that you understand this is going down, like that. So you actually have to put a negative on the percentage there. It's one of the rare cases you do. I forgot to put that in on the other part. Apologies. So moving on. This is the Northern Hemisphere exam 2021. So what we've got is Anna has taken out a personal loan. Interest for the loan compounds quarterly and makes no repayments. Apologies, I'm getting a phone call. I say that interest for this loan compounds quarterly and makes no repayments. After 1 year, she owes $5,328.16. The effective annual interest rate for the first year of Anne's loan is closest to. So, how are we going to go about this question here? We need to know the effective interest rate. But what's important here is that we haven't really been told what is the normal interest rate. So we're actually going to have to find both. How do I do that? I go to my Financial Solver. So I actually don't have the answers to this here. So I'm just going to discuss how we go about it, just because, just for the time's sake, I'm just going to discuss how we go about it. This is in the Northern Hemisphere 2021 exam. The answer here is C for those going along at home, but you can go there and sort of go through the working out. But how do we go about this? First of all, I'm going to go to my Financial Solver, and I'm going to put in n equals 12. I'm going to put I equals, I don't know. That's my question mark. I'm going to put previous value equals, it's a personal loan, so positive 5,000. I'm going to put PMT equal to 0 because there's no. I'm going to put my future value equal to negative 5,325.14, and I'm going to go CYPY equal to 12. I'll find this percentage. Once I find this percentage, whatever it is, I then go and put this in my effective interest rate formula here. So I put that as I. So I would put whatever that was there as I. So put that in here. And I put this as 12, this is 12, and I get my effective interest rate. And what you'll find, this is a 2-step question, and you find that your answer there is C. Now, just because we're pushed for time, pushing on, next one, Ruby borrowed $35,000 from a bank. Interest is charged at a rate of 4.75% on a reducing monthly balance. The loan is to be repaid with 47 monthly payments of $802 and a final payment that is to be adjusted so that the loan is repaid exactly at 48 months. So what it's saying is if I pay $802 for 48 months, I'll pay too much. So at 47 months, I need to then stop and go, all right, how much will I owe with the interest of the last month? And you pay that off. So the way of going through this, I'm just going to show it on the page. is it's 2 steps. So the first step is to go, what do I owe after 47 months? So 47, 4.75, 35,000, take 802. And the future value is what am I finding? This is what I'm finding. This is the one that will be left blank. And then you find it in your calculator. So CY, PY 12, you end up with this answer here. So then on the final month, you say, all right, I've got 1 month left. I want to pay it off after this 1 period. So 1, I serve 4.75. I put in this value as my future value, and I say it's positive now because it's still a loan, like I still have that money. Then I say 0 is my future value, PY, CY, and I go, all right, what is my payment? This is the thing that is blank. As you can see, this payment's actually higher. I actually need to pay a little bit more in the last month to get it done. So the final payment here is $805.57. And that's how you go about that question.